Okay, today we're working on section 3.2. So chapter 3 is all about higher degree functions. Today we're going to look at the graphs of higher degree functions, or actually how to graph a higher degree function. So first off, it's important to know what you're looking for or what your graph should look like. So number one, the graphs are going to be a smooth continuous curve. And that means we have no sharp corners and no breaks in our graph. Okay. Now, the graphs we're going to be doing, technically, if you really want to get specific about it, they're actually going to be a sketch. So we're not going to be graphing a 100% perfect graph, but there are some things, 2 or 3 things to be exact, that we need to make sure show up on our graph. Okay, so we've already graphed straight lines, we've already graphed quadratic functions and absolute value functions. This is going to be graphs of functions where the highest exponent is 3 or greater. Okay. All right, so let's look at the first thing. So first we need to find out, or we're going to be finding out, what happens on the left side of the graph and the right side of the graph. So this is called the far left and far right behavior. Okay. So 2 things can be happening on the far left and far right. Either the graph is moving in a upward direction, or the graph is moving in a downward direction. So we say that the graph is either going up or the graph is going down. And we can determine that from the polynomial. Specifically, we can get that from the leading term. So the leading term is called the dominant term. It will tell us what the left and right behavior of the polynomial is when we graph it. So let's take a look at this. So we're looking for 2 things. Is the term positive or negative? And is the exponent even or odd? Okay. So the first graph we have here, this might have a leading term of something like 3x to the 4th. So 3x to the 4th is positive, and the exponent is even. So you can see up here, when we're positive and even, the graph goes up on the left side, up on the right side. So the 2 arrows are indicating we're going up. So here on the graph, this side, the left side is going up, and the right side is going up. So if it's positive and even, the graph goes up on the left and up on the right. If instead we had a leading term, maybe like 5x to the 3rd, so this one is positive and the exponent is odd. So again, the odd or even is the exponent part of it. The leading coefficient doesn't matter. That's where we get the positive or the negative. So you can see from our graph, when it's positive and odd, the graph is going down on the left and then up on the right. So again, positive, odd, down on the left, up on the right. So these are both when the term is positive. When the term is negative, it just flips over. So if the leading coefficient is negative, you flip your rule. So my suggestion to you is memorize the positive rules and then remember, when it's negative, you just flip them over. So you can see here on the graph, excuse me, negative and even goes down on the left, down on the right, because positive went up on both sides. So negative goes down. So we're going down on the left, down on the right. Negative and odd goes up on the left and down on the right. So memorize the positive ones. So you only have 2 things to memorize. And then just remember, when you have a negative term, it just reverses direction. Okay, so that's the first thing we need to know about our graph. What happens on the far left and far right side of the graph? Let's look at a couple examples with this. So Again, we're only looking at the first term. So I would suggest when you're doing these problems, you circle the first term. And then because we don't need it, cross out the rest of the polynomial. So you don't get confused and you don't look at the wrong part of the polynomial. So 3x to the fifth, this is positive, and the exponent is odd. So the far left is going to go up. The far right is going to go, I'm sorry, I got this all backwards. The far left is going to go down. And the far right is going to go up. So down on the left, up on the right. Sorry about that. All right, our second one here, we got -1/4 times our entire polynomial. So really what we need to do first is we need to multiply this together. And we only, again, need the first term. So cross out everything else. It's not necessary for this type of problem. So if we multiply that together, we get -1/4 x to the fourth. So our leading term is negative, and our exponent is even. So negative and even, the far left goes down, the far right goes down. Okay? So one thing to help you remember this is when it's even goes in the same direction. And odd, if you remember 2Ds, that represents different directions. So even, both sides go in the same direction. Odd, both sides go in different directions. All right, so that's the first thing we need is what happens on the far left and right. The second thing we need to know is specifically what are the x-intercepts of the graph. So we talked about factors before. We talked about zeros before. Now we're going to say that not only are factors and zeros related, but also x-intercepts are related to them too. So first off, we know that on our factors, x minus a is the way we would write the factor of the polynomial. And that means that x equals a, because a would be the solution to our factor if we make it equal to 0. X equals a is our 0. And then that tells us that a comma 0, the point, is the x-intercept. So if you know a factor, you can find the 0 and the intercept. If you know an intercept, you can find the 0 and the factor, or vice versa. So that's the first thing you need to be able to do. We're not even worried about the graph yet. If they give you 1, like here they give us that x minus 4 is a 0. So since x minus 4 is a 0, what that means is -4, 0 is our x-intercept, and x plus 4 is a factor. Okay, so for number 2, x minus 2 is a factor, so that means x equals 2 is a 0, and 2, 0 is an x-intercept. Okay, so obviously we need the x-intercept in order to graph it. So that's what we're really looking for from this. So they may give it to you in factored form, and you just need to find the intercepts. They may give it to you in polynomial form, and you need to factor it first in order to get the factors, and then the zeros, and finally the intercepts. So make sure you can factor them, make sure you can find the zeros, and remember, all three of these are related: the zeros, the intercepts, and the factors. Okay, so here's our polynomial. They want us to find the factors, the zeros, and the x-intercepts. So if you remember from before, we talked about this. The highest exponent in our polynomial tells us how many real factors we have. So basically, the highest exponent here is 3. So we should end up with 3 factors, which means we have 3 zeros or 3 x-intercepts. So every term has an x, so I could factor out an x to begin with. And if we find the factors of 3 that add up to positive 2, you get x plus 3 and x minus 1. So these are our factors. If we solve each factor equal to 0, then we would get 0, negative 3, and 1, and those would be our zeros. And then to get your x-intercepts, you just put a 0 for the y-coordinate with your zeros. So first one would be 0, 0. The second one would be negative 3, 0. And the last one is 1, 0. So these would be our x-intercepts. Okay. So the x-intercepts are what we need in order to sketch our graph. Okay. All right. So when we sketch it, there's two things that can happen at the intercepts. This is the third thing that we need to find out. So either the x-intercept is going to intersect but not cross the x-axis, or it's going to cross the x-axis. Okay. And what you're looking for here, I don't like the wording for this, so I'm going to give you a different way to think of this. We're looking for how many times does each factor occur? Or how many of each factor do we have? Okay. So if each factor occurs an even number of times, then the graph will touch the x-axis. And your textbook says intersect but not cross. I like, well, it touches. And you can see that happens right here. So x plus 2, which our zero would be negative 2, or sorry, our intercept would be negative 2, 0, happens twice because it's squared. That's like x plus 2 times x plus 2. So at that point, it touches the x-axis. Okay. X minus 1 only happens once, and that would be the x-intercept right here at 1, 0. And because it only happens one time, that's an odd number of times. So when it happens an odd number of times, it is going to cross the x-axis, like you can see the graph does here. So our intercepts, the graph will either touch the axis or it will cross the axis. Okay, so let's look at a couple examples, and then we're going to graph this. So this first one, we've got x minus 4 to the third power. So first off, that is the point 4, 0. And because it occurs an odd number of times, that means it's going to cross at that point. Our second one is x plus 3, so that's the point negative 3, 0. And 2 is even. So at that point, it's going to touch. Or as your textbook says, intersect but does not cross. Okay. Our second one down here, they didn't factor it for us, so you may have to factor these yourself. But again, this one you can see every term has an x, and the lowest one is x squared, so we can factor out an x squared. We're left with x squared minus 3x minus 4. As I mentioned all semester long, make sure you are good at factoring. If you still need factoring help, go back and look at your previous homeworks. Go back and practice some more problems. Go back and watch some more videos, or just Google it on the internet. There are tons of videos for you to watch on factoring. All right, so we need the factors of 4 that add up to 3. So we're going to end up with x squared times x minus 4 times x plus 1. So anytime you have just x as a factor, that intercept is going to be 0, 0. And x minus 4 is going to give us 4, 0. And x plus 1 is going to give us negative 1, 0. So again, these are our factors And from our factors, we can get our x-intercepts. So make sure you understand how that works and how to get those. So the x squared, there's two of those. That means at 0, 0, the graph is going to touch. And at 4, 0, and 1, 0, they each happen one time. So at these 2 points, the graph is going to cross. So we've got left and right behavior. We have our intercepts. We have what happens at the intercepts, or the behavior at the intercepts. Now we're ready to graph it. So there's only one thing left that we haven't talked about, and that is number 2 in your list right here, which is the y-intercept. So we need to know where the graph crosses the y-axis. And if you remember from chapter 2, we had this equation, slope-intercept form, and we said the y-intercept was the value of b. Well, if you notice, b doesn't have an x with it. It doesn't have a variable. It's going to be a constant, or a number with no variable. The same thing is true with our polynomials. Whatever value is at the end of the polynomial by itself with no variable, that is our y-intercept. However, if there is no number, like you can see in this example, everything has an x. So in this case, the y-intercept is 0. So if you have a single number by itself, that's your y-intercept. If you have nothing by itself without a variable, then the y-intercept is 0. All right, so here's a list of what we need to do. We need to determine far left and right behavior, get our y-intercept, find the x-intercepts, and then sketch the graph. So notice I skipped number 4. Some people like to find a few more points, but remember, it's a sketch, guys. We don't need to have everything 100% exact. So by the time you get all your intercepts and you know what happens on the left and you know what happens on the right, you've done enough to sketch your graph, and you should be able to sketch it. So first we need to factor this. So I can take out an x squared. And the middle part of this factors into x minus 4 times x minus 2. So we get 0, 0 for our first intercept. We get 4, 0 for our second intercept, and 2, 0 for our third intercept. So let's look at far left and right behavior. My leading term is x to the 4th. So that is positive, and the exponent is even. So remember, that means my graph goes up on the left and up on the right. My y-intercept, there's no number at the end here, so my y-intercept is 0, 0. So only time you're going to have something else is when there's a number at the end without a variable. And finally, we have our x-intercepts. There's 3 of them, but we need to know the behavior. So does it cross or does it touch? Excuse me. So 0, 0 happens twice. That's even, so it's going to touch here. These 2 only happen once. That's odd, so it's going to cross. All right, so for this graph, I'm going to spread it out a little bit. So I'm going to say that 2 spaces here is 1 unit. So 0, 0, we're going to put the intercepts on our graph first. There's 0, 0. 2, 0, we move over to here. There's 2, 0. And finally, there's 3 and 4, 0. So once you got your intercepts, you can do your left and right behavior. So on the left, it goes up. On the right, it goes up. And then we need to touch at 0, 0 and cross at 2 and 4. So we're right here at 0, 0. We've touched, which means we have to go back up because we can't cross. We need to come back down here and cross at 2 and back up and cross at 4. So there's your graph. Now, remember I said this is a sketch. So the only things we're looking for is the left and right behavior and what happens at each intercept. So your intercepts are the correct points, and what happens at the intercepts is correct. Okay? So let me give you an example why I'm saying this is a sketch. Again, we didn't pick any other points. So I don't really know if my right behavior or my left behavior are 100% exact. Maybe my left actually goes up, but it goes up like this. Well, we're not concerned with that. All we're concerned with is that it goes up. Again, we're not going to find any other points. So if yours doesn't go up exactly like it would if we were graphing it 100% perfectly, that's okay, as long as you know that it goes up or down and you've graphed it the correct way. All right, let's look at one more graph and then we will wrap this up. So here is our graph. This time they've already factored it for us. Now that's a good thing. It's also a bad thing in a way, because number one, we can't look at the leading term. So first thing we need to do, number one, we need to find the leading term of our polynomial. And it's a real simple thing to do. All we have to do is multiply all the x's together. Okay? So we've got x times x times x. So our leading term is x to the third. Well, that is positive and it is an odd exponent. So that means we're going to go down on the left and we're going to go up on the right. Our intercepts are pretty simple because we can use our factors to get our intercepts, but we also need to get our y-intercept. So to get the y-intercept, it's kind of like our leading term. To get the y-intercept, we need to multiply all of the whole numbers together. Now, if there were an x out here by itself in front, then the y-intercept would automatically be 0, because remember that x is the same really as x minus 0. So we're multiplying everything by 0. But there's not in this case. So we got -2 times -1, that's 2, times +2 is 4. So our y-intercept is 4, so that's the point 0, 4. And then finally we can get our x-intercepts from the from our factors. So we've got a intercept at 2, 0, 1, 0, and -2, 0. And each of these only happen one time. That means they're all odd. So all three of these points, the graph is going to cross. So once again, put your intercepts on the graph. I'm going to do the same thing here and say that this is 1 unit. So we got 1, 0, we got 2, 0. Maybe they're not too close together. And we've got -2, 0. Okay. And our left and right behavior, on the left, it goes down. On the right, it goes up. And remember, this time, we have a y-intercept of 4. So 1, 2, 3, 4. I'm going to let the y's just be 1 unit each. Again, it's a sketch, so we can do that. So it crosses at all 3 points. So it has to cross here and go up to the y-intercept, come back down and cross, and go back up and cross. So even though it's kind of rough and maybe a little ugly, that's our sketch. So the things I'm going to be looking for on these is your left and right behavior, and that your intercepts are correct, and the behavior at the intercept, whether it crosses or touches, is correct. Okay? Now, I will tell you on WebAssign, when you do your homework, these types of questions are going to be multiple choice. So you may want to take a few polynomials and just practice graphing them on your own so that you are ready when we take the test. Or maybe on the quiz, you might have to graph one. Okay? So that's section 2. Again, the 3 things we did were find the left and right behavior, find the intercepts, both the x-intercept and the y-intercept, And finally, determine what happens at the x-intercept, whether it touches or crosses, so we can use all three of those to sketch the graph. That's it for section 2. Don't forget your homework assignment. If you have any questions, remember you can log in during office hours and get help for what you need on those. All right, that's it. Have a great day. We'll see you next time.